It says here that point P, which is labeled by xy, intersects the unit circle. So this is a radius 1 circle. And that represents the x and y coordinate of the radius 1 circle. So we're just going to drop down our perpendicular to get our x and y distances. And we can then use that point xy to determine the slope. So for part A, slope is equal to rise over run. Well, that's x and that's y. And that's going to be rise over run. Okay, so slope is equal to xy. And for part B, how do we get the tan theta? Well, tan theta is slope. So we can say tan theta is y over x. Now, I've generalized this for quadrant 1, but this is true for all quadrants. So for part C, write the results for the slope in the form of part A in terms of sine and cosine. Well, since this is a unit circle, we know that the x actually is represented by the cosine value of the angle theta. So the ratio is actually the x positioning in a unit circle. The y positioning is given by the sine of the angle in the unit circle. So these sine and cosine in a unit circle actually represents the length. So if for part C, if I were to write tan theta, or slope in terms of sine and cos, well, it's going to be sine theta divided by cosine theta. Okay, so in terms of our slope in terms of sine and cos look like this, sine over cos, and we can then, since slope and tan are the same, we can say that the tan is equal to the rise, which is sine, over run, which is cosine. This is true not just for a unit circle, but for all circles, because regardless of how big this circle is, that ratio of sine to cosine will stay the same. So that's how we can determine tan theta when coordinates. That is not part D, actually. Part D asks for, from the answer for part C, explain how you can determine tan theta when the coordinates of point P are known. We can determine tan theta from the points x and y. So tan theta is going to be found from x and y, and we could also, so we can say tan theta is, you can use the x and y coordinates, and we can also use the slope. Okay, we can also say that it is slope. So it's equal to sine over cosine, and that's all equal to the slope value.